From Nora. Nora has a background in both agronomy and breeding, and she has a PhD looking at water use efficiency and drought tolerance in barley. And then since that, she's been working with us for 5 years in our program. So she's our main interaction point with the breeders, and today she's going to tell you about the work that we've been doing with the wheat program and interactions with conservation agriculture. So, welcome, Nora.
Okay, thank you very much, Nille. Yeah, so as Nille said, today I'm going to present like a manuscript that we have submitted to Field Crops Research. So the title is Durum Wheat Selection Under Zero Tillage Increases Early Vigor and is Neutral to Yield. That is a study that has been done in collaboration with the Durum wheat breeders, like especially Karim, of course, and the back then still conservation agriculture program. So this study has quite a couple of years. And so like the main focus or the interest of this study was to test what would be the effects of doing selection under CA. Would there be like any disadvantages? So this is essentially like a parallel selection experiment. Yeah, a bit to the background. So CIMMYT promotes conservation agriculture as part of its sustainable intensification strategy. I think everybody knows that. But only minor parts of CIMMYT's experimental station are actually managed under CA practices. So just to, I mean, probably everybody knows, but just to recall, so CA consists of the minimum tillage, crop residue retention on the soil surface, and crop rotation. And yeah, as I said, so while we are promoting this, we actually don't really live it on station. So most of the part of the station is occupied by the breeding programs, but I call it now agronomy program because we've changed the names a couple of times. So we are like basically the people who do the conservation agriculture work. There's some station management also doing reduced tillage, but usually since the breeders are like the largest group that occupy the space, this is not like a permanent, and that's not a permanent treatment. Of course, that can be seen a bit critical. No? So if on the one hand we say, okay, like conservation agriculture is essential for us to, or is one essential part for sustainable intensification, but we don't really live it on station. Yeah, that's a bit tricky maybe to justify. And the other question is, so if we promote CA, but we do all the breeding under under conventional tillage, do we actually provide proper varieties for CA? And also, so would CA maybe benefit from varieties that are developed under conservation agricultural conditions? And on the other hand, of course, there's the question, are there any negative effects of selection under conservation agriculture if those lines or those varieties then later are used in conventional tillage conditions? Because what we also know is that while we promote conservation agriculture, most farmers use some form of tillage. Now a bit about the previous study that was published at the beginning of last year. In this we looked at the evaluation of yield progress and genotype by production system interaction in red wheat and durum wheat lines. So this is a study that included 26 lines that were developed between 1965 and 2007, included both like durum and red wheat lines, and those were evaluated in 6 growing seasons, and 6 winter growing seasons in Ciudad Obregón. Those lines were tested in permanent and unconventionally tilled beds with full and reduced irrigation. And what we found out from this is that breeding progress was achieved in all systems. Overall, the effect was like breeding progress was very similar in all of those systems. So you can see this here in the figures. You have it here like results for yield progress in red wheat and here for durum wheat. Below you see like the year of creation, and what we can see, like there was progress in all in all 4 systems. Of course, in reduced irrigation, we have lower yields than in full irrigation. But what is more important, that actually between, so here like in blue we have conventional beds, and in green we have permanent beds. And the most important thing here to see is that there's actually practically no difference in the breeding progress. And that is true for both weed types and for both irrigation systems. So basically we can say breeding progress was achieved in all systems, even though selection was done on the on the conventional tillage. And also like the genotypes were formed pretty similar, so there was almost no let's say there was some interaction between genotype and tillage, but it was of minor importance, so there was no like really crossover effects or rank changes that were of importance. And while from that we can say, okay, like we can also recommend these varieties for conservation agriculture. What of course we cannot answer is if conservation agriculture would, as like a selection environment, would have extra benefits. So, and this is where this new experiment came in, like doing a parallel selection under CA and under conventional tillage to see what would those, would there be like benefits of this, or would there also be like negative effects maybe of selection under CA. So in this experiment, Karim developed lines under parallel selection under CA and conventional tillage. And all those lines were then subsequently tested under both tillage systems, to be able to compare really like the effect of those selection. Specific objectives were to determine whether selection under CA resulted in enhanced performance of progenies under CA conditions, but also to assess any positive or negative effect on the selection under CA on the breeding effectiveness, that is, on the ability to obtain superior lines, which include like yield and agronomically important traits like earliness and plant height, which are some of the concerns that are frequently mentioned if selection would be done under CA. So Karim developed 16 F2 populations generated just by crosses he would usually do in his program. So it was not like a material especially selected for CA conditions. So that was also like one of like the purposes of the study, to see, okay, if we do what we always do but under CA conditions, what would be the effect be? So he has simple crosses, top crosses, and double crosses. These F2s were then divided into 2 batches, and the selection started under CA and under conventional tillage. He used a regular shuttle breeding process between Toluca and Ciudad Obregón. And from F2 to F5, like he selected like the most attractive phenotypes, which is like disease-resistant early types, short stature, and outstanding grain fill. Like the selected bulk method was used in F2 and F3, which with like similar amount of plants per selection stream, selected like in those generations. In the F4, then he selected individual plants, and they were threshed and then produced into single plant derived F5 families. And in the following generation, he did. They were increased as bulk, but without any further selection. Per cross, in total, like between 10 and 25 lines were selected, and this resulted in 234 lines selected under conventional tillage, and 250 lines under zero tillage. And the F7 to F9 generations are then those that were evaluated in our like more like the agronomy trial, like that was really done to do the comparison. So it's in total 484 lines that were tested, and 3 seasons in Ciudad Obregón between 2012-13 and 14-15. We had 3 what we call testing environments. That's conservation agriculture with full irrigation and conventional tillage with full irrigation, and then there was 1 reduced irrigation treatment that had also conventional tillage. Yeah, so the planting process was like the normal, we had like a preceding irrigation for all treatments, then 3 to 4 auxiliary irrigations in the full irrigation treatment, and 1 auxiliary irrigation in the reduced irrigation treatment around heading. Fertilization, of course, a bit higher in the full irrigated treatments, and then pest, disease, and weeds everything was controlled to keep those stress factors as low as possible. Traits recorded were NDVI. We used here 2 values, an early vigor value around 4 weeks after planting, and the maximum growth, which is about flowering time. And then we used days to heading in the analysis, plant height, and yield. We did different kinds of analysis. What I'm going to present here is just the comparison of means between those 2 selection streams, and that I present per environment. Environment is here defined as a combination of an agronomic environment and the year, so we can better see like in which years and which conditions do we find differences. So we have here like the selection stream and the genotype within selection stream as fixed effects, and the repetition is random effect. Yeah, coming to the results, I start with the NDVI, or like what we have as early vegetative growth. In this figure, you can see here below the different years of harvest, like 2013, 14, 15, and the different testing environments. So we have conventional tillage with reduced irrigation, and 0 tillage. And the bars show like the means of the selection of the different selection streams. So in blue, it's like the mean of the genotype selected under conventional tillage, and in orange, selected under 0 tillage. So first thing you can see here is that early vigor and a 0 tillage environment is always lower than a conventional tillage. That is something that we frequently observe. The environment is a bit more a bit harsher in the beginning for the seedlings. So initially the growth is a bit slower. So that is something we expect to see. The other thing you can see here is that plants that are selected under 0 tillage are always the values are always a bit higher. And although this is it's not much, but it's a consistent effect that we found. It's always significant, with the exception here of the first year. So that indicates also for this trait, the selection under 0 tillage is more straightforward. So you have a more difficult environment. So you might see plants that are especially doing well, just more easily. When we go to maximum growth, we see that the differences are between 0 tillage and conventional tillage are not so high anymore. That is also something we usually see. So 0 tillage plants catch up over the season, and the effect between the 2 selection streams is actually not of importance anymore. We have one small effect here, but in general, it's not of big importance. Yeah, then days to heading. Days to heading is one concern for selection under CA. That the idea is a bit that due to better water availability, selection could be in favor of later plants. That then in conventional tillage conditions would be too late. What we saw in this study is that there are some differences. I mean, in general, you can see the differences we see are very small. They are significant because we have it's because it's a lot of lines. So it's, but what we can see is there's some in some years it's like slightly higher, and if plants are selected under zero tillage, and in other years they're slightly higher if selected under conventional tillage. But those differences are about 0.4 days, so it's practically not of a concern. Yeah, the other topic is plant height. So we generally observe a bit better plant stand in conservation agriculture. So one of the concerns is also that if you select under CA, you select plants that maybe would lodge more easily in conventional tillage conditions. In fact, we do see that a couple of like very small effects of plant height that if selected under zero till, plants are a bit higher, but this is with a maximum, like in this average, is a maximum of 7 millimeters. So it's also well within the range of what could be acceptable. No? And then, of course, the most important thing, grain yield. We can see here in the first year that plants selected under conventional tillage have slightly higher yield, but that is not an effect that we could see in other years. And again, so those differences are quite small, so it's like a maximum of 90 kilograms per hectare. So also not really of a concern here. Yeah, this is a biplot of the side regression model for grain yield. In blue, we have the lines that are selected under conventional tillage, and in black under zero tillage. And you can see it's all pretty mixed, so there's not like a clear separation. And that is also, I mean, in accordance with like the results we saw, so there's not really like a difference between both selection streams. And the other thing is that you can see here on this side in red the testing environments, and what we can see is that actually like the difference between the testing environments is not that big. No, it's like the difference is more like there are more difference between years than actually between the testing environments, and that also confirms like our results. No, why we didn't really see much difference between the testing and selection environments. Yeah, for the early vigor, which is where we had like the most, let's say, most consistent effect, we can see a bit more of a separation. I mean, it's still mixed, but you can see on the left-hand side, you see more of blue numbers, and on the right-hand side, you see a bit more black numbers, and that is what we also saw. No, like we saw like a slight positive reaction to selection under zero tillage conditions for this trait. Yeah, just to sum up, so we couldn't observe any negative effects of selection under any given tillage system on the breeding process and yield. So selection under zero tillage and conventional tillage actually led to very similar results. Selection under zero tillage might improve early vigor, especially if you include parents that have actually different for this trait. So as I said before, so the crosses that were part of this experiment were just regular crosses in the program, so there were no specific traits selected to be included. And then from an agronomy point of view, so yield of lines from both selection streams performed better under conservation agriculture. So we always observed high yields. So for us, this means, like, on the one hand, we can, we don't need to be worried that we recommend varieties that are not suited for CA. So it seems like in this setting that we are working in, so of course we CIMMYT lines have wide adaptation. So that is of course an important part. So we don't need to worry to recommend lines that don't work on the CA. They seem to work on the CA. And on the other hand, maybe like the excuse for breeders not to work under CA. So, well, maybe there's like a chance like to talk about how we could have more area, as also for the breeders under CA, because as it seems from the study at least, there are no negative effects to be expected. Yeah, so I thank you, and I'm happy to try to answer your questions. Natalia.
Yes, thanks, Nora. I just have a question. Did you measure other parameters beyond yield, like quality of the grain, and also probably incidence of diseases?
No, so it was not, quality was not measured, and diseases, everything was like very controlled, no? So I think that is also, yeah, like to keep like disturbances like as low as possible. And I think, of course, if you make like if you have a trial like without disease control, and you have really like environments with like very different conditions, where what is like always like a concern, no? Like they say, okay, yeah, if you have like a lot of straw, you can have like stubble-borne diseases. So if you include this, if you have environments that show this, and you include this, of course, then the outcome might be different, no? So, but in this case, everything was very controlled, no? So, I mean, you're not Obregon, so it's also very high input conditions, like irrigated, so it's also special conditions, no? So it would maybe be interesting to have like the same trial with the same lines in like very different conditions, and the outcome might be a different one. But for like for the setting and that we are working, like this white habilitation, shuttle breeding, and yeah, testing in Obregon, I think it's, well, yeah, it's valid. Yes.
Yeah, I have maybe a long-winded comment, last question. Could you tell us a little bit about your literature review on this topic, and whether your results surprised you? Because we had a seminar a couple months ago by an Israeli professor who works on these topics, and he was actually saying the importance of different genotypes under conservation versus conventional tillage in terms of coleoptile elongation, even the effect of some of the RHT genes on the suitability of some materials for cultivation under zero tillage. And also Michael Baum from ICARDA in January at PAG told us that at ICARDA they found important differences under materials selected under CA versus conventional tillage. So what have you found? And I'm kind of wondering whether maybe it's just that we have only one breeder and we needed replications. So what can you tell us about this?
Yeah, so I heard that Michael Baum had some different results on that, but I haven't seen anything published. So while I know, we know about this discussion about coleoptile length, we didn't find much evidence that this would really have an effect then on yield, and especially that this effect would be more important than CA than in conventional tillage. Also to have this kind of crossover effect. We're also looking at this part. Okay, so is it worth it? Do we need a special a different, or do we need two different breeding programs? And so for this interaction, we didn't find anything. So I would be interested in seeing what Michael Baum did, but I don't know if he has anything published. And as I said, also with the before, so I don't doubt that there might be, if you have different, what it is, how to say it. So of course we also work in a very special environment with very special material, no? So I think if you have less controlled environments, or if you control less water, disease, etc. Of course, you could have bigger effects. No, saying okay, if you have a completely different disease spread situation in your CA environment, of course, the outcome could be completely different. No, So it's of course what we present here is like for these conditions we are working in.
I asked Michael for data, he never sent me.
Yeah. Yeah. I mean, I was thinking maybe to write to him to see, but I'm not sure like now what kind of long-term what agronomy research they have. Was this data from before, or because I mean they have moved places a couple of times, no? So I mean they're not in Syria anymore, so I'm not sure what are the conditions they're working in. Pardon?
Roy is not with Ricardo.
No, okay. I was thinking about Michael Baum.
Yeah, like I said, Michael Baum did not. I asked him, and he did not send me any data either.
Okay.
But Roy Ben David at the Volcani Institute does have quite a bit of data. He's a physiologist, and he's worked on this topic. So I would encourage you to check the literature and search for something other than your result, because it sounded to me like that might be the more common finding.
Yeah, I mean we have searched the literature, of course. So it's like not that we're trying to publish something that we just stay in our in our little world, but it's just something like within like. So I think it's within like the breeding context. We did not find this.
From a methodological point of view, it is more difficult to show that something is similar or equals, because you can run more and more tests until you find something different. In this case, probably you put the significance at 3 different levels, but is it more important to have the power of the test, or do the test alpha larger than 0.05, because you are interested to show that the 2 methods of selection are similar. And if you use a p-value very low, nothing is significant. I guess that this is something that, I don't know if there is some time to do something for the paper, but when we are trying to, our hypothesis is that the 2 treatments are equals. And then we need to work with an alpha level of significance larger than usual to have a good power and to try to detect more easily the difference between the treatments. But so far the values are very similar.
Yeah.
Even if they are significant or not, the difference in yield or days to heading are very similar.
Yeah. No, and maybe we need to. We don't know if we get maybe another round of revisions, and then we'll discuss with Pancho how to solve this.
I can try to speak loudly. So one question. I was wondering, in terms of the parental genotypes that went into these crosses, do we have a sense of what the variability is for them in terms of any of these traits, so that if there really wasn't any difference, then selection wouldn't have an effect, or so do we know the parental lines?
Yeah. So, I mean that's of course like one of the important points, no? So, you could say like, so what I said before, like, so Karim did this selection, like the crosses with material he would usually use. So the material was not selected for any specific traits. He also said that, there was like a bit like the lack of evidence. What would like under these specific conditions be really important? But yeah, so no, it was not. So it was not specific material like that we know of that would be like with the coleptile length, for example. No, so yeah, it was not just like the regular what he would regularly do. No, and that was also a bit like the idea of the study. No, to see, okay, so if he does what he always does, what would the effect be? And then I think another study could be like having like very contrasting environment and very contrasting genotypes, and see if if there could be an effect. But I think that it was also not the motivation of the study. Caroline?
In terms of management and cost, was that exactly the same between the treatments? Or some adjustments were done for one of the treatments? One disease applications or?
Was there any economic?
It's the same. I mean, if you were doing a study for farmers, so in the trial we managed all environments the same thing. So we didn't really apply for disease. We do apply like the whole station for aphids. So in terms of applications, weed control costs are the same. If you look at adoption of conservation agriculture by farmers, you get a reduction in costs through the reduction through tillage. In high input conditions, if you just take out your tillage and replace it by one herbicide application, you get some reduction in cost. It's not very, very big, but if you add up a lot of hectares, it can be considerable.
And your efficiency for screening diseases was also the same?
But I mean, diseases in Obregón, it's...
No, I mean during the F2 to F5. I think
yeah, but the selection? Like the environments, how can we manage the environments? Is that what you're asking?
No, your efficiency, because during the F2 to F5, you must go to Toluca and select for diseases. And this is where I'm seeing maybe some difficulties for control the disease at the level you want for screening or for select the good ones in both environments, CA and your conventional. Did you notice any difference between the two environments for that specific trait to be done in Toluca?
We'd have to ask Karim, but he never mentioned that he noticed any differences. So, I mean, if you're just asking how is disease pressure different in Toluca, in CA and conventional, I'd say it mostly isn't. From our other trials, no?
You
maybe
don't
a
need
little
to
bit
control
differences are
Sartoria,
small.
control other diseases for
No.
screening yellow rust.
Okay, any more questions? Well then, thank you very much.